Alright guys, we're going to go ahead and get started. Thank you guys for coming. Thank you guys for dealing with a little bit of a late start here, but everything's in place, we're ready to go. So, like I said, thank you guys for coming. Let's get a quick round of applause for Secure State for hosting this. Thank you guys for doing that for us. You know, without places like Secure State, without you guys, there would be no group like this. Groups like this are necessary for our industry to keep growing, for us to keep growing, so we don't become stagnant. We have a couple of simple rules in CleveSec. Those of you that have been in the first meeting will know them well. First rule is simple: don't be a dick. Don't yell out in the middle of people's talks. Don't, you know, it's pretty obvious. Just people are up here trying to present their ideas. We're all trying to build a nice, strong community here, so let's be respectful of that. But at the same time, let's not take ourselves too seriously. You know, we're here to learn, but we're also here to have fun, get to know each other, and learn in a kind of a casual environment. This is not, no one's wearing a suit and tie. You know, this is kind of toned down a little bit. And then number 3, what we call the Fight Club rule. If this is your first night at CleveSec, you will have to speak. So, first, let's talk about where you can find CleveSec. First and foremost is our Twitter account at CleveSec, and also hashtag CleveSec for things you think the community would benefit from, job postings, tutorials, anything that you find interesting that you think everyone else in the community would like to know about. Go ahead and put it on hashtag CleveSec. If we see it as owners of the CleveSec Twitter account, we'll try and retweet it and make sure everybody in the community gets a hold of it, but we're not going to obviously retweet everything that comes to the hashtag, so the hashtag is for your use. Meetup, which is where I imagine most of you came through, is our kind of our main hub. It's where you can find out about all of our meetings that are coming up, where you can RSVP for all these meetings. And please do RSVP for the meetings because we can get accurate counts on food, everything like that. We have discussion forums on there, we have polls, we have different information on there. So go ahead and check that out. We have the obligatory LinkedIn group. I'm not going to put the link up here because it's insane. But you can find it on the meetup. This is our Gmail address. If you have any questions that you don't want the public to see, you don't want to post on the forums or post on Twitter, you have anything that you want to talk to us about directly, you can go ahead and contact us at the CleveSec Gmail address and you'll be going right directly to me. All of the videos, like the one we're recording right now, will be on our CleveSec page here, user/CleveSec. All the meetings are posted as a single video. And which brings me to the Patreon. So we have corporate sponsors like Secure State and Highland Software that provide food for us and things like that, but also there's additional things we want to do for the community. And until we can get some kind of funding to do these things, it's basic things that Marian and myself can afford to put up the money for. So we started this Patreon so the community can help support itself. Basically the idea behind Patreon is, in our case, every time we post a new video, you can donate a certain amount of money. You can say, every time this YouTube user posts a new video, donate $1. As low as $1 is fine. And you can also put a monthly maximum to make sure that nothing insane happens, but we'll be posting only the meetings to YouTube. So that's a great way for you guys to help support the community. Also, a great way to help support the community is to volunteer to speak. We have a great lineup of speakers coming up in the next few months, but we're always looking for more speakers. Your talk could be only 5 minutes, it can be an hour long, it could be more. Just talk with us and let us know what you plan on doing. We'll work with you, we'll get something together so you can speak at a CleveSec meeting. As of right now, the second Tuesday of every month, which is now, is our conference night and our networking. And the last Tuesday of every month is our community night, where we go to pubs, we have a movie night coming up. We do something a little more socially oriented, a little less security focused. So make sure you guys spread the word. Bring your developers, you know, bring students that you know about, bring anybody that you think would be interesting. We're trying to reach people, you know, that are just outside of the InfoSec Twitter sphere, I guess. So, tonight's agenda. First, we'll have From Executable to Exploit by Mr. Kevin Basista, and then we will be having Doing Bad Things to SQL Server from Mr. Howard Pincham. Those are our 2 talks tonight. So, now is the dreaded time. First timers. So basically, Basically, all I want is just come up, and you don't even have to stand in front of the camera if you don't want to. But we want everybody in the community to know everybody else. We're trying to build an actual community as opposed to just LinkedIn connections, line items on your resume. We want to build something real. So just come up and say your name and something interesting about yourself, or what you've learned about security, anything like that. So I'll start. My name is Chris French. I've been in application security for about 1.5 years now, mostly dealing with education. And I recently bought a guitar about 6 months ago, and I have no idea what I'm doing with it. Who's next? Oh, it's close to you.
I'm right here. I'm Mark. I work here at Secure State. I've been here for about 7 months now, and I just moved from Wisconsin. So it's nice to meet you all.
Thank you.
Hello, I'm Ron. I've been doing IT and security for about the past 15 years. I'll be starting a job at Lincoln Electric in about 1.5 weeks. And this is my first time here. It's nice to meet everybody.
Hi, I'm Andrew Hennessy. I'm a master's student at Case Western Reserve University in the Electrical Engineering Department, and I'm researching hardware security, so related to software security.
Howdy, I'm Doug Highwiller. I'm one of the organizers of Cleveland Lock Sport, so those of you who like to pick locks, come talk to me.
I'm John Winsley, and thank you for inviting me to speak tonight. I'm interested in computer security. I have been for a long time. One of the interesting things about me is when I was 10 or 11, I started trying to write viruses in BASIC. I wrote one that just was basically an infinite loop that printed on the screen, "You have been infected with the blaster virus. Mwahaha." And I was thrilled when an antivirus actually flagged it as something dangerous.
I'm Melissa Schmitz. I am pretty much a noob in all of this, and I'd like to learn some new stuff.
How you guys doing? Mark Adair, sysadmin, local government area. I'm originally from Youngstown. Definitely interested in anything security, IT, tech, gadgets.
I'm Gary McCulley. I've been working at Secure State 5 years now. My big specialty is application security. I also do audit and compliance and also firewall stuff, all that fun stuff as well. And before coming to Secure State, I worked at National City Bank.
Robert Miller, also work here at Secure State. Been in IT for 16 years, IT and IT security. Do the defense work.
Okay.
What's your
My name is Zed McCall, and I work for the Fowler Company doing building automation.
Thank you guys. It's not easy to get up here, especially when you didn't even know you were going to have to do that. But it's a great way to break the ice. Let's give one more round of applause for everybody that came up tonight. All right, so with that, we'll go ahead and get into our first talk, Mr. Kevin Basista.
All right, hello everyone. Can you hear me pretty well? I'm not sure where to hold this, I guess right here. Okay. My name is Kevin Basista. I'm going to be talking about executables and exploits. So the point of this talk is basically to talk about what a program is, what it's made of, how it actually executes. Here? Okay. All right, sorry about that. Okay. Then we're going to have a brief introduction to assembly, like really brief because it's pretty complicated. And then we'll talk about smashing the stack or doing stack-based buffer overflows. So what's the point of this presentation? Basically, we're trying to learn the very basics of how a program is created and how it's run. Enough to give everyone an idea of the concepts without diving into the really hardcore details. I think this is important because it helps to demystify exploits in assembly language at some point, and hopefully will remove some of the intimidation factor you might have if you're looking to get into this more low-level stuff. Who is this talk for? Definitely not for pen testers, definitely not for exploit developers, but for people who have been in InfoSec for a while but haven't had the opportunity to look at this kind of stuff, or someone who's brand new, or developers especially. Okay, so quick note, I'm going to be using Linux and x86 32-bit architecture for this presentation. The general concepts will still apply to other architectures, but the things we'll talk about here will be specific to that. So let's look at an overview of the program lifecycle, if you will. So basically, a program starts off as source code, then it gets sent to a compiler, and the compiler turns that source code into an executable program. Then a programmer or user executes that, and the loader loads that program and turns it into a running process. So now that we have a overall big picture of that, let's look at each of these in detail. So I think a good question to ask when looking into this kind of stuff is, what is a program really? I mean, we use programs all the time, every day, but I think a lot of people don't understand how they're run and executed. So how does a program, how is it really created by the compiler? How does the computer know what to do with the program? And what actually happens when somebody executes it? So like I said earlier, it all starts off with source code. Source code is just some code that defines the logic of the operations you want the operating system or CPU to do. There's a lot of different languages and they all describe different ways to do the same thing. But in the end, the source code is really just text in a file. It's nothing in and of itself. The real star of the program and processes is the compiler. So what's a compiler? It's basically a program that makes other programs. It creates programs from the source code, and the big thing with a compiler is that it's not, it basically implements a language in and of itself. The language doesn't live in the source code, the language lives in the compiler. So the compiler is a program that somebody wrote to adhere to a specific language specification. So when you compile something and you say like int foo equals 0, that gets turned into certain machine instructions that the compiler writers decided that's what the instructions will get turned into. It doesn't have anything to do with the source code itself, but more with the compiler and how it interprets that source code. So an important note as well, compilers will compile an executable or a program for a specific architecture. So if you compile something for 32-bit, that'll work on 32-bit architecture. Those programs won't be portable to other architectures like ARM or whatever. So compilers are super complicated, and I'm not trying to do like a 2-hour talk on compilers, but I hope that gives you a brief overview of what it does. I mean, in effect, it just takes the source code, turns it into machine code. But at the end of that process, did we actually make an executable? The answer is no, because the compiler itself doesn't make executables. When you think about compiling a program, what actually happens is the compiler creates object code, which is basically the actual assembly language of that program, but there are holes in the program where you can hook other code into and create an actual program. So that's where the linker comes in. The linker actually makes the executable. So the compiler creates the object code, and then the linker actually takes the object code and turns that into something that an operating system can run. Linkers are super complicated also, but really all you need to know is that the linker takes object code and formats that into an executable. So to sum up what we looked at so far, basically source code goes into the compiler creates the object code is taken by the linker and turned into an executable program. So now we have an executable. How does it actually run? Well, the operating system can't just run code. The operating system actually needs the code to be formatted in a specific way so that it can know what to do with that code. And that is a file structure or file format, and we have different executable file formats for different operating systems. Linux uses ELF, Windows uses PE and COF format, but we're going to be talking about ELF because this example is for Linux. So basically, the linker will take the executable and take the object code and link all the other code that it needs, puts it into a file format that the operating system can understand and parse. So let's look at the ELF file format. At the top here, we have an ELF header, which contains a lot of important information about where it can be run, what kind of program it is, and information about the sections and headers in the file. The program header table basically helps the operating system set up the executable in memory. The text section here is where the actual machine code is located. The RO data is read-only data. That's the section where you put things like strings and other hard-coded things you have in the application. And then the data section is where the user-defined variables are contained. So there's a lot of other sections in ELF files, but these are the main ones that I think are important and pertinent. So after we have the ELF file and you double-click on it and another program executes it, what actually happens with that file? Well, the operating system calls another program called the loader, and the loader parses the ELF file format and it decides, using the information in that file format, decides where things go to where things should be laid out in memory. It also sets up the first entry point for the program to read run. So basically, it'll put the memory address of the first instruction to be run so that the CPU knows this is where it should start. So once the loader puts a ELF image into memory, it's going to look something like this. Basically at the top we have the command line arguments, the environment variables, and then next we have the stack, and then we have our RO data and data sections, and then at the bottom we have our text section. As you can see on the side here, I have high memory and low memory. This goes from high memory to low memory. So if you can see there, the stack is in the middle between the high memory and the low memory, so it grows down. So what is the stack? The stack is basically a data structure that just has data piled on top of each other, and it has some specific operations that you can perform on that data. So this is what a stack looks like. You just have Bob, Alice, Bar, and Foo, and these are just different pieces of data within the stack. So the stack has two operations that are defined for it. Push, which adds a piece of data to the top of the stack, and pop, which removes a piece of data from the top of the stack. So visualize, it looks like that, super awesome animations. And then pop looks like that. So cool. So basically, when you pop a piece of data, you remove it from the top of the stack. When you push a piece of data, you put it on top of the stack. So like I mentioned earlier, the stack actually grows down because the stack starts in high memory and it grows down towards lower memory. So this is actually pretty important later on. So why is the stack an important data structure? It contains a lot of important information like we saw earlier, like command line arguments and environment variables. But it also has information like parameters passed to a function. It has local variables, and it also, most importantly, stores the return address of the next instruction to execute. So let's look at what we've learned so far. Basically, source code gets sent to the compiler, which turns that into an executable program, which when executed by a user or another program, gets loaded by the loader and gets put into a running process in memory. So now let's take a look at assembly after we've seen the somewhat high-level life cycle of the process. Before we get into the details of that, I just want to show really quickly how the CPU works. I mean, this is obviously super abstracted. There's a lot of stuff that is going on with the CPU, but Basically, it takes in machine code from the process that was mapped in memory by the loader. It executes instructions, and to aid it in doing the operations and instructions, it uses registers, which are much faster pieces of memory that aren't in main memory. And these registers basically uses these to store data and do operations on the data. So the registers are actually really important. They're kind of like variables in assembly language, so they're used a lot. Some of the most important registers I've got listed here. First one is the instruction pointer, EIP. This is probably the most important. It's the register that holds the next instruction that the CPU will execute. So that's pretty important. EBP and ESP, these two registers hold information about the stack. EBP is the base pointer for the stack, and ESP is the stack, points to the top of the stack. The rest of these registers here, EAX, EBX, ECX, EDX, BSI, and EDI, those are all general purpose registers. Sometimes they're used for very specific things, but in general they can be used for anything. Just a side note, on 32-bit systems, these registers are 32 bits wide, which means basically the register can hold 4 bytes. So when someone says a 32-bit system, or they're talking about the width of the CPU or something, they're talking about how much information the register can hold. And in 32-bit systems, it's 4 bytes. So as I said earlier, EBP and ESP help keep track of the stack. So the EBP pointer points to the base of the stack, and ESP points to the top of the stack. So when data is removed, ESP is incremented because it's moving towards higher memory. But when something is added, it's decremented, and it goes down towards lower memory. Okay, so now that we got that stuff out of the way, let's talk about assembly language a little bit. So assembly language is basically just a mnemonic for binary machine code. So people are really bad at reading binary ones and zeros, so we made up a language that would help us understand it easier and to parse it easier. The instructions, the mnemonics that assembly code has are just logical operations that are performed by the CPU. These have a direct one-to-one relationship with the machine code itself. So assembly instructions usually follow this format. Instruction followed by destination and source. So instruction is the mnemonic that's going to be executed by the CPU, and the source is the source variable, and the destination is where the operation will end up. So this is Intel syntax. AT&T is another type of syntax where these are reversed, but I'm going to stick with Intel. I think most people use Intel, so that's the format that's here. So here's a couple examples of some instructions. First we have move EBX EAX, and I read it that way because it's source destination. It makes more sense to me. But basically you're moving the data from the EBX register into the EAX register and just copying it over. The next one, add 0x01 ECX. You're just adding 1 to the ECX register. And then finally we have sub 0x28 ESP, and there you're just subtracting 0x28 bytes from the stack point. So what's with 0x in front of numbers? 0x denotes the hexadecimal numbering system, which is a base 16 number system. Because we're not very good at reading binary, we decided to represent binary data in hexadecimal as well, so it could be more readable to us. We're used to seeing things in base 10, but hexadecimal is in base 16, which is a little bit easier to read than binary, I guess. It's pretty important though in low-level stuff because it's used to represent memory addresses, opcodes for assembly language, and ASCII characters and data in general. So, like I said, we use hexadecimal to represent binary. So when you're looking at an assembly language instruction, it's basically the assembly language mnemonic, which is represented by hexadecimal, which also represents then the binary machine code. So hexadecimal uses 0 through 9, but additionally it uses A through F to define 10, 11, 12, 13, 14, 15. So it doesn't look like base 10. So here's some examples of hexadecimal numbers. A good way to think about it is that when you have something in the first digit, that's a power, So a good way to think about it is that each of these represents a power of 16. So the first digit represents 0 16s, the next digit represents 1 16, or I'm sorry, 1 256. I messed up, I'm sorry. 0 represents 0 16s, 1 represents 16 16s, 256, 2 represents 2 256, and then 3 represents 40 96. So if you look at a hexadecimal number like this, basically to convert it into base 10, you would say I have 0 zeros, I have 1 16, 0 256s, and 0 496s. So this number is equal to 0x0010, which is 16 in decimal. And then another example here, we have 0 B's, 16, we have 3 16s, 0 256s, and 496, we have 0 496s. So that number is 0x003b, and it ends up being equal to 59 in decimal because 3 16s plus 11 equals 59. Okay, some more important assembly instructions. Push, pop, jump, call, and return. So push and pop are operations that are executed on the stack. As we saw earlier with EBP and ESP, the stack is kept track of by the CPU that way. And when you do a push, you decrement ESP, and when you do a pop, you increment ESP. And then jump allows you to jump to another address inside the code. Call will call a function. So if you call an address, it basically sets up the program to call another function. And then return will return from the function. So instructions also use addresses as well, not just data. So in this situation, we have EBP minus 0x10, and we have square brackets. So what this means basically is that the assembly language is going to resolve EBP minus 0x10 to an address, and then instead of using that address as data, it's going to access the data that's located at that address. And then the LEA instruction stands for load effective address, so it's basically taking the data that's located at this address and putting it into EAX. So, pushing and popping and calling and returning instructions, how does that work with the CPU and the stack? So, whenever you call a function, you actually create another stack frame on the stack. And a stack frame isn't anything super special, it's just another copy of the stack that's local and specific to the function that was called. So there's always one stack frame for main, but each function after that also has its own stack frame created. So if we look at our process layout from earlier and zoom in on the stack, you can see what stack frames look like. Basically, when a call instruction is executed on a function, a new stack frame is allocated. There's EBP and ESP pointing to the top of the stack and the bottom of the stack. So when you call a function, a new stack frame is allocated, and then EBP and ESP are updated to reflect the current stack frame. So to recap, the CPU uses registers, like variables in assembly language. The EIP, ESP, and EBP registers are pretty important. EIP stores the return or the next instruction to be executed. ESP and EBP keep track of the stack. Assembly language instructions are basically just mnemonics for binary machine code, and hexadecimals used to represent a lot of those things. And then stack frames are created with every function call. So now that we've learned all that stuff, let's try and get into the actual smashing the stack base buffer overflows. So what is a stack base buffer overflow? It basically takes advantage of the way that the process runs. As we saw earlier, the stack grows and shrinks depending on when you add data or subtract data from it. So if a function allocates space for 10 bytes for something, it will make room for 10 bytes on the stack and make sure that ESP is decremented enough to make room for that. Unfortunately, there's not any checks that are done that will verify that actually 10 bytes were written to that variable. So if an attacker is able to control that variable and write more than 10 bytes into this variable, it'll start messing up the rest of the stuff on the stack. Specifically anything above. So why did I say above? It's because when you're writing data to a local variable on the stack, it actually grows up instead of down. So The stack frames actually grow down when you allocate more memory, but when you're writing to local variables that are on the stack, it grows up. So there's a bunch of stuff that's important on the stack, like I said earlier, and take a look here, we can look at an example. So if I have this char number local variable, it's got room for 10 bytes. Above it is another local variable called answer, and then you've got your return address there near the top. So if I end up writing more than 10 bytes into this local variable, like 13 bytes or so, then I'm going to end up overwriting part of the return address. And this return address, like I said earlier, is used for the CPU. So the CPU will actually execute this address once it's done with the current stack frame. So in order to do something with that, we can take control of EIP and actually tell the CPU what the next instruction is that they should execute. Basically, the idea is that we want to write an address on the stack there that points to our own code. And then the CPU will execute that. So how do we do that? What does that mean if we have control of an address? Well, basically, we want to use shellcode, which is basically just a bunch of assembly instructions that we created, put that on our local variable or on the stack somewhere, and then have EIP jump to that address and start executing it. So a lot of times people will use like remote shells or elevate privileges or whatever, code like that. They'll put that into their stack buffer and then jump to it and have it execute. I'm not actually going, well, I'm going to try and do a demo, but I'm not actually going to write my own shell code. I'm just going to use stuff from Metasploit. So, all right, demo time. Okay, so here I have a, oops, that's the wrong example. Same thing. That would be cool.
There's nothing up there.
Oh, okay. It's gonna be tough. Wait. Yeah. So here's just a small program that I wrote. Basically, you have a local variable name here, it has 128 bytes. Answer, which is 4. It takes one argument and copies it into the name buffer. And then it asks if you want to play a game, yes, no, whatever. The game is guess a game, the answer is 42. Okay, so, wait, I gotta put my name there. Save. So I pass my name as a command line argument to this program. So if I would like to play games, I guess. It says, what number am I thinking of? I don't know. Wrong game number. Okay, so let's see what actually is happening inside this program. So this is the disassembly of the main function we were just looking at. You can see that we're pushing EBP and moving ESP into EBP here. This is basically setting up the stack for this function and saying we're making EBP, we're saving EBP on the stack, then we're making EBP and ESP equal the same value. Here it does stacking alignment, and then here it makes room specifically, what is it? I don't remember. 0x0a bytes room on the stack, and then it starts executing some assembly code. So down here you can see is they're called a string copy, and this is where it copies in my name variable from earlier. And yeah, okay. So let's let's just put a bunch of input in there. Actually, I want to do that. So I'm going to run this program again, and I'm going to pass it as a command line argument. Way too much data that it can't hold. So if you look at the source code from earlier, there's only 128 bytes that are allocated on the stack for this particular variable. So if I just put a bunch of junk in there, it'll ask me if I want to play a game. And the reason for that is because I have overflown the stack, but the return address that was overwritten is the one for the main function frame. And it hasn't returned from the main function yet, so it hasn't crashed. So it's asking me if I like to play a game. If I say yes, now it's in the stack. It created a stack frame and it's in the function guessing game. What number am I thinking of? I say 11. It says wrong, game over. But since now it's returned from the guessing game function and it's also returning from the main function, that address that we overwrote gets put into the instruction pointer from a return. And you can see here the instruction pointer is trying to access memory at 0x414141, which is the ASCII equivalent of a bunch of days. So, okay, we know that we can crash the program with a bunch of input, but how in the heck do we know where we should put the return address? So I'm going to use Kali Linux really quick to generate a shellcode pattern. So I'm going to use a tool called pattern create, which basically just makes a huge string with a specific pattern, and I tell it, here I'm asking for 256 bytes of input. It's going to create this string. Now if we put this string into our buffer, we should be able to ask Kali later, at what offset was the EIP overwritten? Well, no, I can't see this. Okay, hold on. Okay, we need to put it in. I don't know. All right, so now we can see that it tried to crash accessing this memory address. And we'll take this number and ask the pattern offset function, or I'm sorry, pattern offset program. I already saved it from earlier. Awesome. We'll ask this program where exactly in all that string of data was the EIP overwritten. So it was overwritten at offset of 140. Cool. So now we know that at 140 bytes into this buffer, we need to put our return address to get executed. So I have some shellcode pre-prepared that might work. It'd be fun to find out. So basically, in the shellcode that I kind of, massaged here. So first we have 24 bytes of A's, followed by 116 bytes of our shellcode. And this shellcode is basically assembly code that creates a user called CS with password P, and it should probably be root. And then after the 116 bytes of shellcode, we'll have 4 bytes for the address of the shellcode. Now the return address is probably different because I couldn't figure out how to turn off ASLR on this thing, so I'm gonna have to try and see, figure it out. Okay, so we put our bunch of junk in our buffer. It says blah blah blah. Would you like to play a game? No. Okay, so it crashed. This instruction, yeah. Okay, so it's different. All right. So what I'm going to do is, set a breakpoint at. We'll just do it right here. Set a breakpoint here. And then execute it again, and figure out where our shellcode is in memory. Okay, now I get the breakpoint. Cool. So we wrote all that stuff onto the stack. We should be able to see it. So in order for us to see it, we just need to look at memory that is on the stack. So I'm just going to look at 256 bytes that are above the ESP register. So this is most of the data that's on the stack right now. We can see here's a bunch of A's from our shell code. And then our shell code actually starts at this address. So we'll take that address and we'll modify this to make that the return address. This is backwards because of Indianness, and operating systems use little endian, big endian. The operating system actually reads bytes in reverse order when it's executed, so we have to switch it around. All right, so I'm just going to quit. Continue, yeah. Okay, it fails. All right, so then now with our shell code that should have the correct address, this should work. All right, it didn't work. I gave it a shot, I guess. So it should say that the I'm not sure why it didn't work, but anyway, I gave it a shot. The point is the return address gets overwritten and then it ends up in EIP, so that would give you execution of the program, and then jump to the shell code that we have written in the buffer, and then the buffer will be executed and create our user. So, yay, failed demo. All right, that's it pretty much. These are some of the references I used to get some of the material for this, and does anybody have any questions? Nope. All right. Well, thanks everybody. Thanks for letting me speak.
All right, guys. Let's hear it one more time for Kevin. It takes a lot of balls to do a live demo. It doesn't always work out. But he's a braver man than I. So before we get into Howard's talk here, we have a couple of announcements that we want to go over. Before I get started, though, does anybody else have any announcements they want to talk to the group about, besides upcoming events, which we'll cover at the end? No? Okay. So, first thing I want to talk about is we currently have a poll up on the meetup about whether or not to move these meetings, because our current community night is in conflict with the ISC Squared monthly meeting. We don't know how many people here are also attendees of that meeting. We don't know how it is apparently. We have a poll up right now in the meetup. We'd like you guys all to vote in to see if we should change the date of these meetings, or if you guys don't mind clashing with the ISC Squared. Either way, go on the meetup and please vote and let us know, and we'll go forward from there. Second thing is we have a couple of things in the forums on the meetup we'd like your guys' input on. We have the beginnings of our first community charity product. We want to build a safe holiday shopping guide for the community. Either just a guide that we can distribute, or maybe even hold classes around the city for people that don't have certain kind of computer knowledge about how to keep themselves safe online with all the scams that are happening around the holidays. We're also looking for ideas on how to distribute it, and so we'd like your guys' input there also. So that's also on the forums on the meetup site. Also on the forums, we have a thread to submit new community night ideas. Like I said, we have the community night planned out for the next couple of months, but we'd like your guys' input on what kind of activities you guys would like to do for the community nights. We did our pub night. This month we're going to be doing a movie night. Do you guys just want to go to a bar every month? You know, if that's what you want to do, that's fine. But let's talk about that on the meetup also. Next up is we are looking for a third location for CleveSec. The first location is Highland Software on the west side in Westlake. This is our second location here on the south side at Secure State. We're looking for a third location, which is slightly eastern or more downtown-ish, more close to Cleveland, but slightly on the east side area, so we can cover all areas of Cleveland, so we can get everybody an equal chance to get to these meetings. So if you have an idea for a venue that we could use, go ahead and let us know either at the CleveSec Gmail or on Twitter, whatever works easiest for you. Just get in touch with us or talk to us after the meeting, and let's try to get a third venue going. I have some information on how CleveSec can affect your CPEs for your certifications. We've actually reached out to a lot of the certification agencies, and I've placed this information on a page on the meetup, but I'm going to go ahead and tell you guys what we found right now. So if you have a SANS GISC cert, CleveSec counts as 1 CPE per hour. You just have to provide all sorts of documentation to them, like the date, the content, and proof of your attendance. If you have an ISACA certification, they do not approve meetings like this ahead of time, but if you can somehow map the talk of the night to the domains of your certification, you can use these meetings as a CPE credit. If you have an EC Council certification, this meeting is worth 2 credits. It counts as a less than half-day event. So just log into your Delta account for your EC Council certification, and you can enter the CleveSec meeting for 2 CPE credits. We're talking to ISC Squared right now about what exactly these meetings will mean for that, but they want to set up additional sales calls and things, so we have a little ways to go with them. Okay? Alright. So with that, we're going to go ahead and dive right into our next talk. Mr. Howard Pincham, doing bad things to SQL Server. Give it up for him.
Hey, how's everybody doing? Yeah, give me a moment here to see if I can get my mouse back together again. See me, AC. I can get away with it. At least hope so. Oh, thanks. So my name's Howard Pincham. Good to meet all you guys. I appreciate CleveSec and all of you willing to come out and listen to my presentation. Chris, you get kudos as well. You guys give Chris applause. Chris, Marion, you guys and your leadership, I appreciate you doing all this and going through all the extra effort and background support and keeping community. Chris talked about community and how important it was, and when they came to me and said, why don't you come up and talk, I had no idea what to talk about because I'm one of these DBA data protection guys, and I thought no one wants to listen to anything like this, but I'm happy to present to the community. Hope you guys will come up because I'm certainly interested to hear what you say. Kevin brought back some bad memories from like a long, long time ago, and I think I need to talk to him. I don't know if I want to go back, but it reminded me how much I didn't like that subject, man. I applaud you because you're a serious guy and you know that, and I'm a little bit envious as well. If I understood a little more of that, maybe I could do some of this. Anyway, wanted to talk about SQL Server because it is really the place that you can find, it's the best place to look for sensitive data, important data, data that people don't want to lose. But at the same time, since Microsoft's given free copies away, doing things like, install this on your computer and making SQL Server available to almost every one of their other platforms, It has to be the most misconfigured, ill-properly used device that, or I should say software that anybody's ever produced. It doesn't get a lot of press because you don't see people like me standing up talking about weaknesses. I'll talk about this, and I'm sure you guys maybe have seen some of these videos on Metasploit, that kind of thing. Yeah, that's cute. I want to talk about real life, things you can do, things you can't do, that kind of thing. Just scratch the surface, and we'll go from there. The thing that motivated me to talk about this was Target. You guys, I'm sure you're all aware of that Target exploit, the breach that they had, and the pain that the company's still going through. I can't remember the last time I was at a Target, but I've changed my credit card 3 or 4 times, not by request. I keep getting these things in the mail saying, yeah, there's a breach, change your credit card. I say, thank you, Target, thank you, TJ Maxx, thank you, all those guys. This particular document that I'm showing you was an excerpt from what the Dell security folks say was a secret internal review of the Target breach. And I took this from Brian Krebs' website. I don't know how he does it, but he seems to grab all kinds of things. And you can check this out for yourself. Honestly, if you're into this, it's great reading. I sound like a nerd saying that. Oh my God. It's great reading, honestly. But the objects I circled here are Microsoft Production SQL Server tools, old ones. Brian, the Dell Security Works folks, suspect that these hackers expected, or these attackers expected, to break in, get on a database server, take all the stuff from there, and I guess they found that memory scraping or whatever they did was easier than breaking into the database. But tools like this are really the reason why this stands out. Now you guys might look at me and say, well, Howard, okay, you're wearing a collar, you're one of these professional guys, you got this LinkedIn page, all that kind of stuff. Why are you telling me this? You're an IT professional. You're not supposed to give this stuff up. Well, you guys are all IT professionals as well. And I'm looking at the wrong slide. You guys are all IT professionals too, and we'll talk about that. But this platform is attacked most frequently. This page comes from a website. Check it out. I think it's really awesome. IPViking.com. They have this animated platform. I sit there and I just watch this thing. I heard about it on a podcast. I jumped on this thing. It animates attacks. And if you notice, I ran this thing, I don't know, for half an hour or something like that one day on my desktop. And I was so surprised to see Microsoft SQL Server here showing up at least on the attack list. And notice they're in the top 10. The blue section, I highlighted this in my browser, and the blue section shows Microsoft SQL Server attacks. Now the thing that strikes me, don't know how many people ever heard of SQL Server before. Any of you guys ever heard of it? Anybody use it? Yeah, so. Clearly, you don't want a SQL server sitting on the internet listening for connections. So I'm amazed at the number of people that have their database server sitting out on the internet for people to attack. And they certainly will attack it for the reasons I covered. I said again, yeah, I'm an IT professional, but you guys are too. And I think the biggest problem in our environment is a lot of this stuff gets covered up. You can Google or Bing search these things. I'm not going to get into real details. You'll see some, I think, cool stuff. But you can Google all this stuff. You can read about this. You can buy kits that'll show you a lot of this. The reason I'm here is back to this community. We're this community, right? And we're supposed to be sharing and open. Those of you that know anything about like drunk uncles know you want to hide those guys, right? You keep them in the corner, so you might enable them by throwing him a bottle or two, and then he like leaves you alone. He doesn't show up at your party, he doesn't embarrass you in front of your friends, that kind of thing. And I think we do a lot of this, the same thing with these exploits and undercover risk here for SQL Server and other platforms. And if you don't talk about it, like the drunk uncle, if you don't expose them, get them help, clean them up, he's just going to show up over and over again, and then there's going to be a real problem. He's going to show up in front of the cops, and the cops are going to arrest him, you have to bail him out, all this kind of stuff. In our terms, gee, you know, we cover up these exploits and these problems, you're going to end up in a position where you're looking for new work, or your company is looking for new CFOs, CEOs, CIOs, the whole 10 yards. What I'm saying is, go and tell it. We'll talk about this, and my intention here isn't for you guys to take a bunch of notes and then go try this out on your network or among your friends and all that. What I'm saying is, hey, when I talk about this, go find, you know, your database professionals. When you're out and about, when you're concerned about your own environment, I'm saying, you know, tell your leadership that, hey, these exploits are real and they don't get talked about because people think a database server is a black box. But it isn't. It's just another program that has a ton of risks that you need to consider and you need to mitigate. So I want to talk about three things, three approaches, I guess we'll call it, to doing bad things with SQL Server. First one's the easy method. The one's the so-so kind of method. And the other one's the hard method. Okay? Easy being, hey, you got more privileges in this environment than you really needed to have, and what you could do because of that situation. The so-so meaning you probably have the right privileges and all that, but there's still some things you can do. And then the hard is you don't have really any privileges, and does that matter, or what that matter, or what does that mean, and what you can do, okay? Let's jump right into the demo here. And let's see what we can do. I always hate when presenters get up and they say, hey, just any questions, interrupt me, that kind of thing, because it never seems to work. And I don't know that a lot of times people get questions, but I guess I'll say it anyway. Hey, if you have questions, interrupt me. We can make this interactive. I have no idea how much time I have. I don't have a lot of demos. I hope they're valuable. We'll go from there. And just yell out your questions if you have any while I figure out how I get set up here. This is a program called SQL Server Management Studio. Just to tell you what I have here, this is a simple, straightforward demo. I have a database server running on Windows 2008 R2. Or I should say a couple database server services running on Windows 2008 R2 that run on a laptop that basically run standalone. I don't really have the room for a domain controller or anything fancy like that. And I'll go through these exploits. Some of you might say, well, gee, Howard, you're going to show me some older technology. SQL Server 2014 just came out. Yeah, you're right. You know, if I want to be dishonest, I'd say, well, you know, you'll find this in the environment everywhere you go. And really, you will. But I'm having some licensing issues with my newer servers. So you're going to get the 2008 R2 Windows version, and you're going to get SQL Server 2008 R2, and you're going to get SQL Server 2000, which support for 2000 went away years ago. 2008 R2 support just ended in April. So yeah, we're a little behind, but these concepts still apply, and I bet you're running this stuff in your shops today. So I have I'm going to connect to this database server, and this particular one I call it's what's called a named instance. That means on this host I have two server services running, SQL 2008 R2 and SQL 2000. You'll see me get on R2 first. And to make it easy for me to remember, I call this user Easy because we're doing the easy demo. So this user is set up like a typical user. Now, understand database administrators and others are just like everybody else. Sometimes they're lazy. And when you have an environment where you have a bunch of databases and you have like users, developers, that kind of thing, and they come up to you all the time and they say, hey, I need access to this, I need access to this, sadly you go the lazy route. Or even worse, if you deployed your own, you go the real lazy route and just grant yourself and everybody else on all the privileges in the world, and you just trust everybody. My buddy Warren looked like he just left. Was big on layers, and he sent me this little posting about layers and trusting the layer above you and beneath you. Yeah, don't trust the layers above you and beneath you, as you'll see. So we're connecting to this, and I'm connected to this database server, Win2008 R2 demo, with no user privileges. I have what's called a SQL Server login. That is a principal or an identity that's just known by SQL Server, this particular SQL Server, no one else. And it's called, as you can see in the pop-up, easy. Yeah, I know this is bad, you guys. I'm sorry about the size. My Zoom program's been blowing up my demo, and I can't run it. So I hope you guys can make this out. So what I want to do is, since I'm connected to this server and I have way too many privileges, if I look at myself here, I'm the easy user here. And as I said, you'll see this typically happen because people don't want to get calls. I say, well, I give you all the privileges in this server role. You'll see I'm set up as what's called sysadmin. Man, that's really bad for you guys in the back. Sysadmin. And this particular users in this role can do whatever they want on the system. And that's cool if the scope is just limited to SQL Server. Maybe it's not, right? Because you can certainly damage the data and everything else on there. But the way this is configured, even though I can do anything within the service, I can't do anything outside the service. But I want to talk about how I break out and how I do things outside of the service with the tools that I have. I'm not going to install anything or do anything different. I will run a few scripts, but I'm not going to do anything any different here. So I know I have a solution database here that has some stuff that I want to see on it. So I'm going to open up a little script that I call credit card search. Now, the problem with databases is what? You got a whole bunch of data, and if you don't know anything about the way the data is organized, how are you going to find anything? Well, fortunately, SQL Server makes provision for this, and if you have the correct privileges, you can just search every database, every data element in the entire database for whatever you want. Now, some people would say, oh, I never heard of that before, or I didn't know that was possible. Oh yeah, it's possible. Sure, I have a background in T-SQL and I kind of understand that. But this isn't anything that you couldn't find on the internet. In fact, a piece I stole from the internet because instead of banging my head to figure out how to make some calls, I just grabbed a portion of it and wrote the rest myself. I think my problem was figuring out what was a MasterCard and what was a Visa and that kind of thing. So I have this script that basically goes and looks at an object called information schema tables. It basically says, hey, show me all the tables in the database, and in each table find text columns, and then I want you to evaluate them this way, okay? So I think this is a MasterCard, and this big wildcard search, it's almost like a regular expression, says, hey, show me all these values. Now I need to set something up here real quick, so don't mind the person behind the screen, okay? Because I have a problem here. How you like those Browns, huh? Aren't they awesome? Sorry, I guess I have a bunch of Browns fans in here. I need to check one thing. When my demo broke, I think it took some of my privileges with it, and I want to show you how this query works. So wait for it. The reason that Kevin's presentation gave me such bad memories, I was in we had a class, a compiler class, we called it, and it was CIS 400 something or other. And we had a project, an assembler project like you saw there. And the project, my team member and I, we had to go in front of the instructor, and our project blew up at a certain point, and we knew the instructor was going to ask us for it. So I was in the back waiting for my teammate person to go and reach a point where I knew this thing was going to blow up. And I fixed the data behind the scenes to make sure I got the result, or we got the result that we were supposed to get. And when I got out of that class, and I can't even remember what the grade was, I felt guilty for just a second for manipulating a teacher like that. But I didn't feel bad about getting the grade, and I was happy I got the grade that I got. And I ran away and I didn't say anything else. So that's why assembly language and Howard are having we're going to do a quick switcheroo on you. Those of you that saw me come in here earlier knew that I had a problem on my laptop, and it was my demo. And I thought I fixed everything, and I was so confident running up here, and this is one thing I didn't fix. But it's going to be fixed in a moment. Thank you very much. How you like those Indians? Son of a gun. Okay, so we're going to look at the credit card here a little bit later, but how about the rest of my easy demo? Okay, so I told you that I'm connected to a server that you'll see here called the 2008 R2 instance on this machine, and I have too many privileges. That is, I've been granted server administrator. And that's not so bad. But what's typically bad is when you deploy a SQL Server, if you really want to take advantage of some advanced maintenance functions, like you want to do backups on the fly, and you want to be able to create database or create devices, access certain devices, or if you want to be able to spin up brand new databases and zero fill them quickly and not wait for a background process to do it, you elevate the privilege that your SQL Server service runs under. Now that's not a problem if you do it right, but typically you just put the service account that the account that service runs under the local administrator, in the local administrator group on the machine, to give it instant access to do what it needs to do and then more. So, and if you're handing out privileges like candy and you're elevating, you're not following least privilege, you end up in a situation like this. You have a machine that you can call what's called an extended procedure, and this particular procedure reads the registry on the machine. The extended procedure name is xpreread. Now, when I run this thing, even though I don't have any privileges, any user privileges on the server, I don't get a result set. Oh, I hate you. Okay. Because I didn't run this the right way. Here we go. What I've done here, I'm asking the registry, I said, hey registry, show me a key where the standard backup directory is here. And I'll talk about why I want to know where the backup directory is here. Just by connecting to it, not doing anything, not looking at any data, I can evaluate the registry on the machine that I'm running on. Now, that's handy in SQL Server terms because he needs to change the registry and all as well. And he can on his own, but if I elevate the privileges of the service and if I hand out elevated privileges to my users, which are all common, I end up in a situation like this, that some user just has to read a book and say, hey, I can read the registry. Now, finding out where a backup location is, that's helpful for later on in a later discussion. But let's see what I can find out about the operating system I'm running on. And so I'm going to enumerate a number of values here and find out just some information about just the machine itself. The build of OS, who's registered on the machine or what's the registered owner name is, where the system folder is, what version of the server I'm running, that kind of thing. Great information if you're doing some background intelligence, that kind of thing. But you guys are familiar with the Windows registry. There's all kinds of information all you can get out of it. And I certainly don't have to tell you, but let's have a little fun. That registered user that you saw go by, right here. How's the view in the back, okay? That registered user in the back, let's update that registered key. I looked it up and I found that it's registered owner inside local machine, software, Windows, current version, right? So I want to change it from the current value, Windows user, to you are our own exclamation point. I didn't think exclamation points were even valid in that dialog, but I guess they are now because I'm going to change it. So I changed it, and if I go back and just look at the registry, and we'll check that out when we break into the machine here, what do you know? My registered owner name is you are own. So yeah, these are weak little cute little exercises, right, that I'm showing you. But as you can see, I mean, clearly, if I elevate the privilege of my server with a little bit of SQL, I can manipulate the machine that I'm running on. And I don't even need a local user account on the box. I can be on the other side of the world and do this. That's why I'm saying it's not wise to put even a properly configured machine on the internet, because you have no idea who's doing what. And by the way, all this activity is going on without a whole bunch of logging. I mean, clearly, I imagine if anything shows up in the security log, it'll probably look okay because it'll be the Windows, the service account that I'm running this on. They won't know basically it's me, especially if we do the thing that we normally do and not turn on auditing, which is another whole discussion, right? So anyway, enough with the registry. Why don't we look and see what kind of information we can get from some of these other database servers? So the other nice thing and lazy thing that we do, right? So you have these database servers, and you have a database server for what? Production that has the real live stuff. You have a database server for test, right? Because you want to test before you go into production. You have a development or staging database server, right? You guys probably have those as well, and that all gets tested. So we beat people, developers and all, and we say, hey, no testing in development or no testing in production, right? So what do you end up doing? You test and test, right? What kind of data do you use? Where does the data come from? Any idea where the data comes from? Production. The data comes from production. So how do you get the data to production? From production there. So you can export it from the database, do a bunch of stuff, and then import it back in the database. Or you can take advantage of a cool feature that SQL Server offers that allows, let's call it federated database servers to run, okay? And I'm going to call I'm trying to think what this is called. We'll just call it a construct named Open Data Source. And I'm going to pass this thing what it really amounts to is a connection string. And I'm going to say, hey, we're all in the same network. We trust each other. We're probably running on the same service account. I'm going to connect to you. You give me your data. So like I told you, I'm connected to the SQL 2008 R2 instance. But I want to connect from here to the SQL 2000 instance. And let's pretend my R2 instance is test. Let's pretend I'm upgrading. and the 2000 instance is production. But it could be a 2012 instance, it could be a 2014 instance, right? And I'm saying, hey, this is production. Let me just see what's in the customers table in this database. So I run this thing, yeah, and I got an error. Yeah, I hate you too. Okay, I hate you too. Look at this. So this is another problem that I had. I mentioned I don't have a domain controller, so I had this hack running that I could communicate using my local accounts here from this machine to the other machine. And when that broke early on the day, I thought I hacked this workaround, and I did not fix this. So sadly, I'm going to have to show you how that works on the machine itself. And we can do that. Why don't we just copy this statement, and let's jump over to the machine. See, I appreciate you guys' patience. See, that's what I tell you. You know, stand up, volunteer for CleveSec, and demonstrate how bad your demos run, because mine are just all over the place, let me tell you. So again, let's check this. So I'm on the 2008 R2 instance here, and I want to connect to this 2000 instance over here. And all I have is me connected. You saw that error message. It said, hey, you're trying to use a SQL login to jump to this other machine. That machine is just like this machine, has Windows identities. I don't know SQL identities. So that's a nice, secure kind of function, but I can get around that. I can just log in as the same user, well, not the same user, as a similar user, and just run this thing. And what do you know? Okay, we're running. Let's see if we get any results back. Since I blew my credit card discussion, as soon as I create an account for myself, yeah, this is a fun time, you guys. Okay, we're gonna leave this alone. Yeah, thanks for your patience. Don't forget to tip your server. So, dang, this is just fun here, I tell you. Let me continue here, and then I can jump on as this user, and maybe I have a fix for all of this, okay? So, I didn't demonstrate how you can connect remotely here. I'll demonstrate that for you in a bit. We talked about how you can look at the registry and different values in here. I want to talk about an extended procedure that's really powerful, that I think gets a lot of press and has some real value for us database administrators, but it can be used to do bad stuff. Some of you that are familiar with command scripts and all recognize some of the commands that I have. In SQL Server, again, running as that user I told you about, Easy, who has more privileges than he needs, except when I need to run a demo. He can run and run a statement and just call Windows and run who am I, just like he would if he was at a command line. And you notice the response he gets back isn't Easy that we ran, but it is actually the name of the SQL service. And the security identifier that goes along with it, if you can see that, it is SQL service. And this identity has various group membership, of course everyone, of course SQL user, a special user group that he gets allocated to that we can talk about another time. And administrators, like I told you before. So if my identity is SQL service in this administrator group, let's just do some fun, nice, easy stuff. So of course, the first thing I want to do is create an easy local account for myself. And hey, let's use a password that I can remember, like I0 own you now. How about that? Ta-da! I even got a nice response back from that SQL Server passed back from the OS that said, hey, this thing worked. So I have a user account, and that's cool, but I really want privileges, okay? So the user I'm running under, which isn't easy, is SQL Service, right, has administrator privileges. So let me just elevate my privileges and put myself in the administrator group. So now I can easily remote into the box and do whatever I want. And while I'm at it, I don't know if I like the people that are doing administration on the box anyway, so let me change their password as well. And boom, their password changed. Next time they try to get in, they'll have a problem. So do you think I can really get into this box? I hope so, because everything else is just blown. So let's use that password. And I know I'm going out on time here. I appreciate you guys and your patience. So we said the user was easy, right? And we said his password was I own you now. It's good that we do mixed case and we put special characters in, right? And of course, I can blow by my own domain by just saying, hey, whatever that machine is, connecting to it. So what do you know? Boom. I'm logging in, I get my own profile. So I'm running the box now. The person that knows the administrator account can't get out, can't get in. And probably while I'm at it, I guess I can troll around and blow away anybody else's privileges, do what I want, blow up the box and walk away. Again. Yeah, it's like one of these steps work, but I really want to do that last one that I said I would do and I didn't. So let me just start up Management Studio on this box, and since and by the way, this remote desktop, and here's another challenge here as well. A lot of times we'll just put terminal services or remote desktop services on a box that has all these other services, and we forget that even if you grant people general user access, they can troll around and do things like pick up your logs, pull configuration files that maybe have secure passwords in it as well. All that kind of stuff can be done on these kind of boxes from here. All because someone misconfigured a machine and maybe somebody else who has bad intent goes on Google. So let's just, another nice feature that I have that I'll show you if I have time. A lot of times when we deploy SQL servers, we just throw them in anybody's network segment. And a lot of times we'll do this quick and dirty. We might set this up on some machine that we had, and we know that we got a network jack over here that we'll just connect to. And we know we have a jack that we'll connect to, we'll just connect it. Not realizing that you added a database server. Yeah, I hate you. I hate you. You know, you guys, I tell you, I'm glad you have such a great sense of humor. We're experiencing yet a little bit of a bug here. It doesn't like the name I gave this thing, and we're going to have a little problem. Oh, you son of a gun. Okay, let's check and see if we can browse for more. Let's get on another one. The point that I was trying to make, SQL Server does a nice thing. If you say, hey, I want to know what SQL servers live on my network segment, it'll just tell you. And there's a service called SQL Browser that just helps you, especially in situations where I have two services that are running on the same machine. They can't, of course, be available on the same port. So if I try to connect to the standard port, I might get the machine I want, I might not. Oh, I hate you. Oh. You guys, I apologize. This is like bad. So these machines, card number search. Okay, thank you. Somebody's going to run it. If I connect to the right machine. This is the right machine. The wrong database. So you put this database server on the same segment that all your user machines are on, and that's nice. So your users can just find the database servers that they need to connect to, and it's great. But of course the problem is when somebody else shows up and just jumps on your network, they can inventory all those servers as well. And again, we do these things to make our work easy and reduce our administrative effort, but my point is we expose ourselves in this manner. And if we do that, and if we're doing things like leaving sensitive data on our network or on these servers, somebody's bound to find it and do some bad stuff with it. And that's my whole point. This is the result of a script, finally, that went out and searched the entire database and found a table that these account numbers live in and showed me where they were. And then once I use a script like this and say, oh, I know exactly where that is, if I go to that location, and notice everything's indexed here. It's in the Northwest database inside this payments table. Since I have more privileges than I need, I can certainly open it up. And what do you know? Not only do I have credit card numbers, I have a CVV value, I used to have expiration date. I do have expiration date. Gee, I can go to town on this. By the way, these are like test ones from Visa. They're not real, you guys. This is going on. Sorry, you guys, this isn't real. Sorry. My point was, gee, in bad configuration and doing bad things, we can follow up. Let me share just one more quick thing with you, and I'm going to close up. Like I said, I appreciate your patience. I'm no network engineer. I was telling Gary I slept in a Holiday Inn and I got close to it. So today, yeah, that wasn't funny. So these last few days I thought, well, gee, you know, I've been dying just to sniff something here. Let me get Network Monitor because it's free. And Wireshark, we can't find it anymore, and the replacement, I couldn't remember his name. But I wanted to look and see, hey, when I showed you that drop-down box and I said, hey, how is this thing finding all these servers? This is how. And some of you guys are network experts, and that's great. You guys bear with the newbie. Some of you guys never seen or heard any of this before, so I'll probably look like I'm some kind of genius to you. What happens? So when I open up a box, and by the way, this is everywhere. Here's my Windows 8 machine, and I'm going to run a program, it's already here, called ODBC CAD 32. And I'm going to say the same thing. Where are the SQL servers? And you notice it shows me. I can do this in Excel. I think I can do it in Word. I can do it in all kinds of places. I can enumerate servers that are on my network. And the reason I can do that is this. So when I came on, when I pushed that drop-down box, my machine, the .1 machine, sent out a broadcast to every device on my segment that's here. And that's, in this case, that VM. Hey, do you have any SQL servers? And the friendly device responded back to me. He says, hey, listen, thanks for your message. I got 2. See, I got a response with 2 instances, see that? And the first one I got was the name of the server, along with its instance name, SQL 2000, like you said, like you saw. And then it also shows me, hey, this is the port it's listening on, so you can go to them directly, kind of like a phone book or something like that. And hey, if you want to use name pipes since they're on the same machine, here's the pipe that you use. And there's a second one. And here's a port he's listening on. This is the version that he runs. So I can just look at the version and say, hey, it's not patched. I can do all this stuff. Gee, I can do all kinds of bad stuff. Just by pushing a drop-down box. Clearly, we're totally exposed here. I can go on and on with these demos. My point here is, even if you have more access than you need, if you have no access, you can still do things. For instance, you guys, I don't know, those of you who have never used SQL Server might not have appreciation for this. The so-so user doesn't have access to the credit card numbers I showed you. So that user has a problem. Even if he knows the credit cards are on that database server, he can't get them. But what typically happens with the database server? Well, we're concerned about recovery, so that database gets backed up. And when we back up databases, sometimes we forget to put them in locations that people can't access, or God forbid, we forget to encrypt them. So that means if you ever get your hands on a backup of one of these databases, you just go download a free copy of SQL Server Express, install it on your local PC, restore the backup to your machine, you own the whole database. Since you're a super user on that database, you can do anything you want, or on the database server, you can do anything you want with the database. My whole point about the security piece and what happens with SQL Server, it covers this up. And we can go on and on. You guys, like I said, have been incredibly patient. Let me switch back and just talk about some of these concepts quickly. Well, maybe not. Come on. So, in closing, I say, don't let this happen to you, okay? Of course, you knew I was going to end with that, right? 3 things to just think about, quick and dirty ways to protect this. And you guys, I know I rushed through this, and there's too much more, but you guys got to get home to your families and everything else. Just 3 things to think about. 1, least privilege is your friend. My whole point in all this was, if we'd seen it all, if you're set up in the easy configuration where you have more privileges than you need, you might be the honest person, but the next person around you won't. And the layers above and below you won't either. And if you're running privilege, you can be exposed to many, many, many different things as well. So least privilege is your friend. By all means, keep it simple, single purpose servers, don't run a bunch of services on them. If you're going to do all this fancy dancy security stuff, make sure you isolate these boxes and do a bunch of other things that we can talk about and you can read about, and some references we'll send you later on. Hey, if you have sensitive data, better go out and inventory it. You have sensitive data, you know if you have sensitive data. If the data isn't sensitive, if you got, like, I don't know, your diner checklist or what's on the booze list over here at the friendly desktop, whatever this is over here, that's awesome, great. Don't worry about listing, you know, what's in the booze cabinet under your sensitive information, but credit card information, payroll, all this stuff that either gets you fined, fired, or out of business, by all means protect. If it's sensitive, you know, ask yourself if you have to keep it. Credit card numbers, why keep them? Get rid of them. You don't want those. They're going to end up on somebody's laptop. You're going to have a breach. You're going to have to explain all this. Get rid of them. If you have to keep them, or if you're regulated, encrypt them, obscure them, do whatever. Don't let people like me just tool around with my laptop on your network, find all this stuff and throw it away. And lastly, hey, this is what's called a detective control. Logs are really, really important. It's great that you have logs turned on and running, because by all means it's going to help you in your investigation. But even better, hey, pay attention to them. Sometimes they tell you about odd behavior that maybe you can catch before it gets out of your shop, or before it like goes like over the whole world and nobody can find it, right? My whole point is, you guys go tell somebody about this. We'll follow up later on with some details, but I just want to expose these things and just say, hey, you know, these machines can be compromised as well. Appreciate your time. Thanks for your patience. Wasn't it funny all my demos blew up? And I appreciate your time. Thanks.
All right, guys, give it up one more time for Howard. Howard, if you wouldn't mind actually coming right back up here, we're going to start a new CleveSec tradition tonight. Do you want to come up and introduce this concept? Sure. So this is a concept that Marian and myself came up with. We're going to give little speaker gifts. So if you speak at CleveSec, you'll be the recipient of one of these amazing one-of-a-kind gifts. I'm going to let Marian explain it since it's his brainchild here.
All right, we put a lot of thought into this, so there's a little backstory. There's this awesome account on Twitter called InfoSec Sage, and every day the InfoSec Sage sends out, really inspirational tweets about InfoSec. And we thought, what can we possibly give to the speakers of CleveSec as a gift? And we thought about it, and we looked at items on Amazon, searched around, and we found these little bottles that have a little USB cork on it. So this little cork is a USB drive. And then we're not going to just give this away empty. We have to put something in there. So, so why not put 2 and 2 together? We wrote a little message from the mysterious InfoSec Sage and rolled it up and put it inside the bottle here. And then at the top, there's a little seal of the Sage, so that all of our speakers can have a little a personalized message from the InfoSec Sage for speaking at CleveSec.
Awesome.
There you go.
Yeah, it's up to you if you want to say that.
Should I put this in my lap?
Not saying that Marian is the InfoSec Sage, but no one has seen him and the Sage in the same room at the same time. So Kevin will be getting one of those too, of course, but he works with us, so he doesn't get the same ceremony. So, real quick before we move on, I want to have you guys. Oh, you know what? We'll wait since you're usual. So here's some upcoming events that we have going on. Whoop. My background is the same picture as my slides. Threw me off. There we go. So there's some upcoming events around the area. On the 16th is the next Cleveland Mox Board meeting, and we happen to have one of the organizers in the building, so he's going to come up and say a few words about that in a couple seconds here. After that, on the 23rd in Chicago, there's the Hack for Kids event. That's obviously for kids, but that's happening on the 23rd. I believe sign-up's still available for that. And then on the 3rd of September, there's a conference in Dayton, Daycon 7th, and the website for that is daycon.org. Okay, so Doug, do you want to come up and talk about this? While he's on his way up, how about we give it up one more time for Secure State people for sticking around? They didn't have to stay.
One more sandwich.
One more.
Everybody rush. Thanks, Chris. Cleveland Mock Sport. We have a meeting every 3rd Saturday of the month. We're currently holding our meetings at the Launch House in Shaker Heights. If you're familiar with that, it's right near the intersection of Lee Road and Chagrin Boulevard. We're looking for more people to show interest. We had a presence at the recent B-Sides event, and we got a lot of interest there, so we hope to see some more lock pickers out there. We talk about locks, security, physical security. We have a lot of lock collectors and enthusiasts there, but we also learn how to pick locks. It's kind of fun, puzzle solving. We encourage people to do this legally and just come to learn and share their knowledge with us. So if you're available this coming Saturday, we're meeting at the Launch House from noon until around 3 or so. Just come up and knock on the door, and hopefully someone will be there to answer because they keep it locked up. That's it. Thanks.
Thank you. And then, of course, we have our community night coming up on the last Tuesday of the month, which I believe is the 26th this month. We're going to be having a movie night at Building 3 of Highland Software. We're going to be watching Sneakers. And there's parking information and directions. Everything is on the meetup. So, like I said before, please go to the meetup and RSVP and everything. So we can have accurate counts for food and all this stuff. All right? All right, that's it, guys. Thank you all for coming out, and we'll see you next time.